All right, welcome guys. Good afternoon, good evening. Hello, we are the Garden Gnome Kit, and I am Joshua Clark, along with my colleagues Alyssa Marcias and Curtis Scott. We're going to hear from them later. So our build first started off with Alyssa's concern with her grandfather, and he's becoming a little elderly and having trouble keeping up with his yard. So we came up with this idea of building a kit that will fully automize the complete system of gardening, hence the Garden Gnome Kit. This system, in layman's term, will pretty much just be a plug and play type of system where you'll just simply plug in some sensors, set up your Wi-Fi, and this whole unit will be able to take care of a plant completely by itself. Some of the things that are included in our Garden Gnome Kit are that it will be able to water the plant when it's needed. The kit will also be able to monitor the soil moisture. Also, we'll be able to monitor the ambient temperature and humidity, as well as the water reservoir level. And the user can control this, control the pump for the water supply device and also the lighting system, all through our Garden Gnome app, which will be included with the kit, and that will communicate via Wi-Fi. So here is a block diagram of our kit. It shows the basic components connected to our system. The brainchild is the Arduino UNO Wi-Fi Rev 2. As you can see, all the components are communicating either directly to it or it's receiving information from it for the system to work. Just starting from the left to the right, we have the moisture sensor to the temperature humidity sensor, the water tank level, the Garden Gnome phone app, which will be relaying information back and forth to the Arduino UNO Rev 2 board, as well as the controls that you can use, the water pump and the lighting, which will be triggered through the relay. So going off through each component in more detail, first we have the moisture sensor. You can see it in the middle. It's the two-pronged sensor that will go into the soil and will be able to determine the amount of moisture that is in the soil. It is a non-corrosive sensor, so you don't have to worry about it being rusted. Also, it measures its resistance between the two prongs, and using that information, that's how we're able to obtain the moisture level. Next is the water pump. Right there is just the pump with the power and ground cables. Not pictured is the tubing that's going to be used, that is used to feed the water to the plant. This device is completely waterproof because it will be submerged in water, and it will be controlled through the app using by the user. Here we have is the temperature humidity sensor. You could see in the middle the blue cage. That is where the temperature and the humidity sensor is housed. That information will be sent directly to the Arduino board and then wirelessly communicated to the user's app. Here we have the water level sensor. It's a basic switch that turns on and off. It will alert the user when the water is running low. We don't want the pump to, run continuously when there's no water that could burn out the pump. The switch operates as a float. As the water goes down, it triggers a switch telling the user that they need to refill the water reservoir. And finally, the relay. This component will trigger both the pump and the grow light. The grow light will be powered using a 120 volt power outlet from a wall, and the Arduino board will trigger the relay to send power to the grow lamp and to turn it off when needed. And here is the whole system all together on the left side of the PowerPoint slide. Here you can see the Arduino board is once again in the middle, and we have all the components connected. We have two power supplies, one going to the Arduino board and another one for the light fixture. So you will need 2 wall outlets for this system to work. Other than that, it's completely wireless. Not mentioned on the bottom right of the slide where the circuitry is the breadboard. There is an LED hooked up to the float, and when the water level is low, the LED light will shine bright. So not only will you get the digital alert through the app, you will also get a visual aid with the light shining bright from the breadboard. And finally, here on the right side of the slide is a screenshot of the Arduino app, or I'm sorry, our Garden Gnome app. From the top, there's a switch that allows the user to control it automatically or manually. Automatic mode means that the preset functions are going to manage itself to keep the plant alive using all the sensors and readings that is being obtained. Manual mode will completely override that and allow the user to turn on the light on and off whenever they want, as well as switching on and off the pump as whenever they want as well. But always the data is going to be relayed to the app, whether if it be an automatic or manual mode. And that data is the soil moisture, the temperature in Fahrenheit, the humidity in a percentage, and the water level, which is just normal or low. All right, and that's all I have to say. I'm going to hand it off to Alyssa, and she will continue more.
Thank you. Okay, so what you see here is a layout of our housing unit for our kit. We use Tinkercad to design this layout. Tinkercad is an easy-to-use web app that allows us to design our 3D structures. And what's unique about this is that it's actually true to size scaling. And here we have, it's essentially a box. It's 18 by 18 by 18. And on the left image, you can see a cabinet. This is where we're going to house our circuitry. And then on the right, you can see a small hole, and this will feed the wires from for our sensors through that. So it'll be separate. The bigger hole that you see is where a plant could be inserted. And then on the right of that is our water reservoir. And that will feed water to the plant. Okay, so the Arduino UNO Wi-Fi Rev 2 is the star of the show in our circuit. It's a very compatible open source microcomputer, and it offers 20 separate input and output pins. It's fully programmable and has a built-in Wi-Fi / Bluetooth communication chip. The Arduino UNO Wi-Fi Rev 2 uses the new AT-MEG 4809 microchip, and this chip features an 8-bit AVR CPU core, which allows for high-speed analog to digital conversions. The Arduino UNO Wi-Fi Rev 2 also features Wi-Fi and Bluetooth, as given in the name, Wi-Fi Bluetooth wireless connectivity, thanks to the Nina W10 module. The Wi-Fi network operates solely because of its ATE DC68A crypto chip. And this chip is designed with a cryptographic coprocessor, which allows for a secure communication line. And during this semester and last semester, we were playing around with 2 different Arduino boards. The one that we had previously was just a very generic Arduino UNO board. It didn't have any of these extra accessories. However, we were able to attach a Bluetooth module to it, but it was only solely Bluetooth, and that limited the range of when we connect our apps later on. We can't connect if we're far away, so that's why we went with this board. And in the next slide, Curtis will explain the MIT App Inventor and the Firebase program.
Okay, sorry. So how our communication works is on the left here. We have where the Garden Gnome kit, it's going to send all the information through Firebase. What Firebase is, it'll hold the information. We can either put information in or draw information from that. So from the Garden Gnome kit, we're sending, the low water alert, the temperature, the moisture, and it goes to this Firebase. And then from the app, the app coding pulls the information from Firebase. And how we do that is through MIT App Inventor, which the coding for that is a little different. It's using blocks, and that's what's shown on the right there. So this is the coding for the app itself. And that's how we pull the information from Firebase. We can also send information back the other way to control the Garden Gnome kit with the lighting or the water pump and putting it in automatic or manual mode. And so here's the video. Let me know if you guys can't hear it.
Normally there's music playing in this video, but I'll go ahead and just talk over it. So here you can see I'm putting my hand over the temperature humidity sensor, and the readings on the app will change. And then next, we're going to operate the grow light. So I'll flick the switch real quick. It's really hard to tell because it's bright outside, but it turned on and off there. Probably the trickiest part we had with this build was getting the water pump to work. We were having connection issues, but here we're able to get it to work. And we show that the water level alert is triggered at the bottom of the app. So right now it's reading low, and that's telling the user to refill the reservoir. It goes from low to normal. Here, and we are testing the moisture sensor. So you can see I have the sensor out of the plant, and then when I stick it into the plant, the data changes. That's a photo of what the circuitry looks like in the back with all the components connect. Well, the computer chips connected.
And that's that. Sorry, I didn't know you could hear it. I could have spoke over.
No, that's okay.
So next up, so that kind of shows how everything works. And here we have the budget that we used. Uh, came out to about $530, which isn't too bad. We have multiple copies of just about everything because we were working separately from home, so we all wanted to test it out ourselves and work on it ourselves. Possible extensions would be, controlling more plants than just one, having a bigger garden, or a more sophisticated garden that you could specify each plant being a different type of plant and needing its own specific watering requirements. Bluetooth capability, or using a cloud-based system for control anywhere you have internet, or multiple facilities at once. So that's just multiple garden gnome kits from the same app. And we'd like to thank Professor Abdelrahim, CSUB, and Best Cabinets. They were the one who actually built our box for us.